Hello, Mr. Barry's geometry class. I'm looking at your practice worksheet 13.5. This is April 22nd, and this is due on the 23rd. So I want to take a look at this. I'm going to be writing the answers down on this paper over here as I'm working through this. I figured I might as well just work through it right along with you. I'm going to do the odd ones. And if you can do the even ones, that would be fantastic. I want to leave you with some even ones that you could work on your own. I want to explain the odd ones though. A die is rolled and a spinner is spun. Find each probability. So here's just a visual. You have a spinner that only has A, B, C, and D, and you have a die which is 1 through 6. So what's the probability of getting a 1 and then spinning an A on the spinner? So that's going to be 1/6 times 1/4, which it will be 1 out of 24. That would be the probability. If you are to go further than that, you would just do 1 divided by 24. Not sure if he's telling us to do that. Let me see. Let me go to his website just to see if he has any further directions on there. Just show work. That's all he says, show work. So, we could stop right there. But, if you wanted to, I'm not going to do this with each one, but you could do 1 divided by 24 and get, that would be 4.17, about 4.17% chance of that happening. Okay? That's if you're going to divide that. I'm going to go down to number 3, composite and C. Composite numbers that are on here are going to be 2, 4, and 6. So you have a 3 out of 6 chance. And C is going to be 1 out of 4 chance. So that's going to be times 1 out of 4. And that's going to equal 3 out of 24. Taking a look at 5, probability of getting a 1 and then spinning an E. So that's going to be 1 out of 6 times, there is no E, so 0 out of 6. So that's going to be 0 out of 36, or 0% chance of that happening, because you could do the first one, but you can't, because it says and get an E. No chance of that happening. Why are these independent events? I want to help you with that one for number 6. It's because they are these events occur using different items. Okay, one's a die and one's a spinner. Okay, that's why they're independent. They're independent of each other because they're on 2 different items. Okay. All right, so for 7 through 11 in a bag, there are 3 red marbles, 2 yellow marbles, and 1 blue marble. So that's 3, 4, 5, 6. Once a marble is selected, it is not replaced. So you take one out, now you're going to be dealing with 5. Take another one out, now you're going to be dealing with 4, so on. Find the probability of each outcome. So a red marble and then a yellow marble. So red marble, we're talking 3 out of 6. And then a yellow, now you're talking about 2 out of 5. And this is going to equal 6/30. These, if I divide both the top and the bottom by 6, I get 1/5. And I could divide 1 divided by 5 in order to figure out what the percentage is. Let me jump down to number 9. A red marble and then a blue marble. A red marble would be 3 out of 6. And then a blue marble will be 1 out of 5, because now you're dealing with 5. And so you're going to be 3 out of 30. If I divide both the top and the bottom by 3, I get 1/10. 11, a red marble 3 times in a row. So now you're gonna have 6, and then you're gonna have 5, and then you're gonna have 4. But so there's 3 red, right? And if you pick it the first time, now you're gonna have 2, and you're only going to have 5 in there. And then if you pick it the second time, you're only gonna have 1 red marble left, and you're only gonna have 4 total in the bag. So that's going to be 6 out of 1/20th. If I divide both the top and the bottom by 6, I get 1 over 20. And to find the percentage, just take 1 divided by 20. All right, so for 12 through 16, in a bag there are 3 marbles, 2 red marbles, 2 yellow marbles, and 1 blue marble, same as above. After a marble is selected, it is replaced. Using this new situation, find the probability of each solution. So you're going to redo some of these. So I'm going to go back and I'm not going to redo these. This would just change, you'd have a 6 down here. Number 9 would change, that would be 14. 14, this would be a 6 down here. So you'd have 3 over 36. And then number 11, which is number 16, this would be a 6, and this would be a, well, you keep putting it back, so it would be 3 over 6, it would be 3 over 6, and 3 over 6. Okay, that's for your number 14, or number 16, sorry. I'm going to do the odd ones though, so this might help you out with, your number 8 and 10. So number 13 for number 8, you're going to do this, but you're putting it back. So that is going to be 1/6 times 2 out of the 6. And that's going to be 2 out of 36. This would equal 1/18. Okay, because the yellow are 2 and then the blue is 1 out of 6. So you just multiply those together and you're putting it back, so that's why you're dealing with 6 again. 15, exercise 10. So exercise 10, any color marble except yellow and then a yellow marble. So that one would have to be any color except yellow, because there's 2, so that would be 4 out of 6. And then a yellow, you put it back, and then you get 2 out of 6. So that would be 8 out of 36, or 2/9. Okay, that's 15. All right, working on number 17. Each spinner is spun once and find the probability. So we have the probability of, we have 2 different spinners. So a 2 and a B. So a 2 is going to be 1 out of 4 and a B is going to be 1 out of 5. So 1 out of 4 times 1 out of 5 is going to give us 1 out of 20. It's supposed to be a 2, sorry. Number 19. An odd number and a vowel. Well, there are 2 odd numbers out of the 4, and there are 2 vowels out of the 5. That's going to equal 4 out of 20, which is going to equal 1/5. If I divide both the top and the numerator and denominator by 4. Okay, here for mutually exclusive events, I'm going to just put this over here. Mutually exclusive events. For this part of the page, we are just to determine if a scenario involves mutually exclusive events. So let's take a look at the first one. I have a spinner has an equal chance of landing on each of its 8 numbered regions. After spinning, it lands in region 3 or 6. These are going to be mutually exclusive. So for number 1, mutually exclusive. Okay, because we're talking about those specific regions of 3 and or 6. 3 or 6. Okay. Let me talk about before I go to number 3, let me go to number 2. A bag contains 6 yellow jerseys numbered 1 to 6. The bag also contains 4 purple jerseys numbered 1 to 4. You randomly pick a jersey. It is purple or has a number greater than 5. So these are not mutually exclusive. Mutually exclusive. I just wanted to give you an example of one that's not mutually exclusive. Okay. Number 3 is going to go here also. Number 3 is going to be mutually exclusive. A magazine contains 12 pages. You open it to a random page. The page number is 8 or a 10. And number 4, to give you another example of not mutually exclusive, a box of chocolates contains 6 milk chocolates and 4 dark chocolates. 2 of the milk chocolates and 3 of the dark chocolates have peanuts inside. You randomly select and eat a chocolate. It is a milk chocolate or it has no peanuts inside. That's another example of a not mutually exclusive. Okay. Now for finding the probability for let me just do 5 and 7 on this one. I do want to leave you with 6 and 8 on your own a little bit. A magazine contains 14 pages. You open a random page. The page number is 3 or 7. Okay, it's 3 or 7. So that would be, 2 out of the 14, or that would be 1/7. And that equals, it's approximately, if you were to divide that, it would be like 14.3% or something like that. And then number 7, you roll a fair 6-sided die. So it's just a regular die, 6-sided. The die shows an even number or a number greater than 3. So even number or a greater number than 3, that is going to be 4 out of the 6, which also equals 2/3, or if you were to divide that and get the percentage, you would get 66%. Okay, hopefully this was helpful to you on these 2 pages, and good luck with the ones that you're on your own with, and if you need help more than this, please let me know. Thanks.